Hello. Conditional probability is the probability of an event F, assuming that another event, for example, E, has already occurred. We call this the conditional probability of F given E. F given E, and we write it like this. F vertical line E. An example of conditional probability is when we roll two six-sided dice, for example. An event total is 3, given that total is even. So we, so to say, consider the new sample space. The total is even. And what is the probability of getting 3 when the total is even? Of course, it is impossible since 3 is an odd number and the probability will be 0. Another situation, what is the probability of total of 3 given that the total is odd? Let's call it A prime. A prime is another event. So this time the probability is not 0 because from all odd outcomes, there are 18 to have total of 3. So actually when you roll two six-sided dice, there are all together 36 outcomes, and 18 of them, 18 outcomes have odd total, 18 have even. The total of 3 can be reached only by 2 outcomes, 1 and 2 and 2 and 1. So only these two combinations of showing on 2 dice give the total of 3. These are examples of conditional probability, and we have used so-called special rule for computing probability or conditional probability of events in a sample space with equally likely outcomes. The number of the events in the intersection divided by the number of outcomes in the event E, divided by the total in our new sample space, so total of odd outcomes, which is 18. So let us consider another example. Again, we roll 2 dice. The first outcome is the total showing is greater than 9, and the second, what is the probability that the total is odd? The total is odd given that the total is greater than 9. Probability of O given G. Event G, the total is greater than 9. We can show all the outcomes that satisfy this event. We have the same sum on the diagonal. So here is the diagonal with a total of 9, 3 and 6, 5 and 4, and so on. And we are interested in a total of 10, 11, and 12. These outcomes have total greater than 9. The second event is the total is odd. According to the special rule, the probability of this intersection will be given by the formula, the number of outcomes in the intersection, odd and greater than 9, divided by the number of outcomes in this given event, a new sample space. The given event is odd, the number of outcomes in the odd. Intersection consists of these two events, 5 and 6, 6 and 5. They both have total of 11, greater than 9 and odd. So the number of outcomes in the intersection is 2. The number of outcomes in the event G is 1, 2, 3, 4, 5, 6. So the new sample space, the given event is greater than 9. So That's why the number of outcome in G is in denominator. Then we can simplify the fraction dividing by 2, numerator and denominator, 1/3 is the probability of odd given G. So here elements of or outcomes of these two events are listed. We can also show them on the diagram, on such Venn diagram. We represent set G as a circle, including all outcomes or all elements of the set G greater than 9. Every element is an ordered pair, 5 and 5, 4 and 6, and so on. Then we have another set, odd total. We don't need to list all the outcomes here in this problem, since we need the intersection of the event odd and event greater than 9. There are two elements in the intersection. Then the probability of odd given G, as we have already found before, 2, the number of elements in the intersection, divided by total, by 6. The total is the total of the given event. This given event is a new sample space. Let us compare this result with the probability of total greater than 9, given total showing is odd. So now we want to find probability of G, given that the total is odd. We must divide the number of outcomes in the intersection, greater and odd, by the number of outcomes and the new sample space, of the given event. Given event now odd. The number of outcomes in the event odd. Intersection is the same, 2 outcomes. Number of outcomes in the event O is 18. There are 18 ordered pairs with the odd total. And we can simplify this fraction 2/18, dividing by 2 numerator and denominator, and we get 1/9. So this is the probability of the event G given O. So, of course, it is a different number because it is a different situation. General rule for computing probability F given E. So the formula is almost the same. The difference is that now we have not the number of outcomes, but we have here probabilities. Probability of intersection divided by probability of the event E. We compare probabilities, not the numbers of outcomes, and this is the difference of general rule from the special rule. Suppose that State Bureau of Labor Statistics conducted a survey of college graduates comparing starting salaries to majors. Let us consider a couple of situations. If the selected graduate who was offered between 40,000 and 45,000, what is the probability that the student has a degree in the technology? We select only the student with the starting salary from 40 to 45. This is our new sample space. If we call event F, the question is, what is the probability that the student has a degree in technology? Let us call this event T. So we want to find probability of T given F, 40 to 45,000. So it means that we consider the news, we are interested only in the events, in these events. So this is the new sample space, and we use the general rule, the probability of the intersection getting technology, and 40 degree and 40,000, 40 to 45,000 divided by the probability of 40 to 45,000. Probability of getting probability of the intersection. The intersection is 8. Probability of the intersection is 8 divided by the total 100. Probability of getting from 40 to 45,000 is 15 divided by 100. Can multiply by 100 numerator and denominator, so 8 over 15. Let us also find the probability of students if we get a student with a major in social sciences. What is the probability that the student get below 30? So what is the probability of getting below, given that it is the social science student? The probability of intersection of these two events, B and S, divided by the probability of the given event, social study. Probability of the intersection, social sciences, is 3 over 100. Probability of getting a degree in social sciences is 18 over 100. So we can multiply by 100 numerator and denominator and get 3 over 18 and divide by 3 numerator and denominator 1 over 6. The probability of getting a salary below 30,000 given that degree is in social sciences. If we consider the general rule for computing probabilities, so this is the fraction, so the probability of F given E equals probability of the intersection divided by probability of E. If we multiply this formula by P of E, we will get the following formula. Probability of the intersection E and F equals to P of E times P of F given E. So we have found the formula for probability of the intersection. So this is the probability of event E multiplied by the probability of event F given E.